Today we get to look at the factor theorem. In our previous video we said that when you get a polynomial and you multiply the quotient by the divisor and you add the remainder, then you get the polynomial. This was derived in our previous video. We arrived at this in our previous video when we were looking at the remainder theorem, and we said that for us to get the value of r, then x minus a should be equal to 0. It means that this whole term will have to disappear, so that if the value of x in the polynomial here is a, then we are able to get the remainder. Now, if the value of x, if we put the value of a here, and we calculate and we get our value of r as 0, then it means that this divisor is a factor of that polynomial. So this is what constitutes the factor theorem. Like now right up here, it is saying that if x minus a, which is the divisor here, is a factor, then r is equal to 0. This will be equal to 0 if this is a factor. If this is not a factor, then we will get a certain remainder. It could be 2, 3, or whatever number. So if r is equal to r, it will be equal to 0 if p, when we have put a in that, when we substitute a in the polynomial and we get the answer as 0. Therefore, if p of a is equal to 0, then x minus a is a factor, and that is what is constituting the factor theorem. So let's do an example. Looking at that example, they're telling us that show that this polynomial is divisible by x minus 2. Hence, find the other factors of the polynomial. So now, if this factor is divisible by this polynomial, if this polynomial is divisible by x minus 2, then it means this should be equal to 0. X minus 2 should be equal to 0. Therefore, if we are to show that this factor can divide this completely, it means that our value of x should be equal to 2. If we put this value of x, which is 2, we put it in this polynomial, and our answer is equal to 0, then it means that there is no remainder, and it means that this x minus 2 is a factor of that. So we begin. So it means that 2x cubed plus x squared minus 13x plus 6 is equal to 0. So we substitute. So it becomes 2 into 2 cubed . So when we substitute for the value of 2 in this polynomial, we are going to end up with 0. So that means that indeed, therefore, x minus 2 is a factor. Now, if x minus 2 is proven that it's a factor, hence, find the other factors of the polynomial. So we need to find the other factors of this polynomial. So we use long division to find the other factors of the polynomial, like this. 2x cubed, divide that by x, you will get 2x squared. So 2x squared multiplied by x is going to end up with 2x cubed. Then 2x squared times negative 2 will end up with negative 4x squared. When we subtract these two, this minus that will remain with nothing, 0. The x squared minus negative 4x, this will become a positive. So this plus that is going to give us 5x squared. Then we pull these other terms down. Here we have minus 13x plus 6. We continue. 5x squared, divide that by 5, you'll end up with, this is positive 5x squared, divide that by 5, divide that by x, you'll end up with 5x. So it becomes plus 5x. 5x times x will give us 5x squared. Then 5x times negative 2 will give us negative 10x. So this minus that will give us nothing, 0. Negative 13x minus negative 10x. Of course, this minus and that minus will become positive. when it becomes positive, it is 13x, negative 13x plus 10 will give us negative 3x. So it's negative 3x, then plus 6. This one comes down, plus 6. So we continue. Negative 3x, divide that by x, you remain with negative 3. So negative 3 times x will remain with negative 3x. Then negative 3 times negative 2, you will remain with positive 6. And when we subtract this minus that will remain with nothing. 6 minus 6 remain with 0. So you will find that when you get this polynomial, you divide it by that divisor, you will get this quotient and no remainder. So it means our general term, which is our polynomial, which is p of x, is supposed to be equal to the divisor, which is x minus a, times our quotient q of x plus our remainder. But now here we are tasked to find more factors of this polynomial. One of the factors we have found is that one. The other factors that we need to find we're supposed to simply prime factorize this, because this becomes p of x is going to be equal to x minus a. We have x minus 2. Multiply that by the quotient, which is 2x squared plus 5x minus 3. Now the remainder is 0 plus r. Our r is 0 because these are factors, so even if we don't include it. So to get other factors, we simply need to factorize this quadratic equation. So factorizing that quadratic equation, it means that we're supposed to get two numbers. One of those numbers giving us a sum of positive 5, and the other number is giving us a product of negative 3 times 2, which is going to give us negative 6. So if we land on 1 times 6, 1 times 6, 1 times 6 will give us 6, not negative 6. So if we made this a negative, 1 times negative 6 gives us negative 6. 1 plus negative 6 gives us negative 5. So let's make 1 negative, this is positive. So negative 1 times positive 6 gives us negative 6. Negative 1 plus positive 6 gives us positive 5. So the two numbers will be negative 1 and 6. So we'll use those two to replace this middle term in our prime factorization. So prime factorizing, this is going to become, we'll continue with that later. This prime factorizing 2x squared plus 5x minus 3 is going to become 2x squared. Now this plus 5x is replaced by these two, so it's going to be minus x plus 6x. Then we'll come to this minus 3. So that is going to become, we pull out the common terms. The common factor here is x, so it becomes x into 2x minus 1. That is plus, what's the common factor here? 3. So it becomes 3 into 2x minus 1. And then our answer here will be, we have the common terms in the brackets being the same, so it becomes x plus 3 into 2x minus 1. So this, now we've prime factorized this quadratic equation. So these now come and replace this. It means that our original statement there is going to become p of x, which is our polynomial, is going to be equal to x minus 2. Multiply that by this, which has now become this, x plus 3 into 2x minus 1, like that. So now they're asking us, our question was requiring us to find the other factors in the of this polynomial. One of those factors was already given to us, it was x minus 2. So it means the other factors are x plus 3 and 2x minus 1. And that's the answer. Thank you for watching this tutorial. Please don't forget to like and share this video. For more videos, simply subscribe to Kisembo Academy. Otherwise, I hope you watch the next video. For Kisembo Academy, This is Arnold Rangakuramia.